Welcome back to another episode of a podcast written by a software engineer. I'm your host, Perry, and guess who's back? We got Andy and Stan on the show. Stan, how you doing?
I'm good.
What about you, Andy?
Good.
Awesome, man. Yeah, for the people actually, haven't been part of this journey so far yet, or just, starting with this episode, today's topic, actually, we're going to be talking about development cycles. And that's basically how tickets, where they come from. We refer to them as tickets, but they're mostly tasks. In terms of, if you're working on a project, you always have features coming in. You want to add a new button, you want to add a new newsletter sign up to do that. Those are all, feature requests that comes in, and how you actually deploy them varies between organizations. So yeah, we're going to explore a bit of that. But yeah, you want to give us a little intro, Stan, for the people that haven't met you before.
Yeah, sure. I'm a engineer at Notable. Been here around 3 years. So seen our deployment process kind of evolve a little bit over that period of time.
Yeah, and I guess it has. And also, I'm pretty sure you have previous experience at other companies that do have a sort of, deployment plan or the development cycle that might be different. So we're definitely going to dive into that. What about you, Andy? How long have you been an engineer? And what's your take on development cycles?
Yeah, I've been a software engineer for a little over 3 years now. My view on dev cycles is that it's incredibly important. I think process just makes things a lot easier.
Yeah, I think one of the interesting points is going to be when we talk about dev cycles in smaller teams, it's a little bit easier because you have maybe one or two people deploying at the same time. But when we talk about massive organizations, they have 500 engineers or even more, and how does that even deploy when it's a single project, when you have a single app that you have so many people working on? How do you make sure that change is going in there? Does don't mess anything up. So I guess I could do a quick intro about myself. I'm Perry. I currently do work at Notable as well. And in terms of looking at different dev cycles and all that, I think that has been the habit since day one. I think since the first day I've worked as a full-time engineer, it's been a process that everybody explores. So when we're talking about code reviews, when we're talking about quality assurance, when we're talking about deploys and all the CI/CD, fortunately that has been very present in my experience so far. But yeah, with even the given stuff today, the first thing I could kind of dive into is what is a development cycle? Are there other names that people go by talking about it? So when was the first time you heard about development cycles then?
I don't know if I heard about it very explicitly until my first job. And even then, a lot of it is just being exposed to how you basically write code and eventually get that code into production in some way. So that entire process, I think it goes by various names. I've heard development process, development cycle.
Yeah, and I guess the other terms probably that comes to my mind is sprint related or agile, or I think those verbs kind of lob in that category. Even though it doesn't describe specifically a development cycle, I feel every time somebody mentions agile, I think that's a topic.
Yeah, a lot of these topics are very tangential, how we release product features, and oftentimes these product features are tied to releasing code as well. So oftentimes they go hand in hand.
And somebody works in tech when they throw the word agile out there. It's it's just something that I feel everybody gets on the same page with. But that's a good context in terms of if people have heard about these terms, we are definitely diving into this topic. And then if we're just starting with a question, there's what is a dev cycle? For example, Andy, what are the different steps, I guess, in the dev cycle that you've seen, I guess, in the past couple of years?
Some basic steps I can think of is probably just speccing out what you're trying to build. That's probably the first step, just taking a look at exactly what you're trying to build, what you have. Next part is probably the largest block, just writing the code or doing whatever changes you need to develop what you're trying to develop. And the last part is probably some way of testing, whether it's automated or manual. And then the final part is just deploying those changes and pushing that stuff out to prod.
Yeah, that totally makes sense, right? Because stuff obviously needs to be built before you can actually release it. So in terms of the chronological order of that makes sense. And I think that's very standard, I guess, across the companies. I feel if we're talking about a skeleton of the development cycle, I don't think any company is skipping any of those steps. All of them were going to have some sort of deving time because that's when you built the stuff. If you want to be a little bit more specific, there's a layer of code review after you're done deving it, which is where somebody else will check your work. And then after that, there's going to be, I guess, the QA phase. One interesting point that Andy mentioned is that sometimes you do your own testing before you even put it into CR just because you have to have a bit of vetting or else you're just blindly releasing stuff at that point. And then depending on the size of the team as well, there's also dedicated like QA teams that actually look at, what is being put out, and then that kind of get merged onto master. And I guess the end result, the deployment, is basically, that's when the end users actually use it. And if there's anything that goes wrong at that point, then that's when you're going to hear a lot about it. So yeah, I think we all agree kind of with the dev cycle. Was there any like more steps you want to add in between that, range that we were talking about, Stan?
Maybe not steps, but I think it's important to kind of make a distinction between like developing a product versus developing like code. Like there are cycles to releasing code, and there are also cycles to releasing product, and there may be some overlap in those cycles. But I would say product is more general. Like let's say you want to release a feature. Sometimes releasing that feature doesn't always involve like a code change. Like you might just be setting up some human manual process first to actually, provide some kind of functionality for your end user. But then eventually you might want to automate it. And then when you start writing code, there's kind of like a process to that as well to make sure you're delivering code that's stable, that, works in the future.
Yeah, like no merge conflicts. No, that's
something like that. Yeah, that's definitely part of it. Probably a small part of it, but
yeah. I mean, nobody's happy. Somebody was complaining about merge conflicts the other day, so I was like, gotta mention it at this point. But I do like that spin where a lot of stuff that we're going to be talking today is definitely going to be more like engineering, software engineering related at the end of the day, mostly because like, we write code. If you look from the outside from somebody, if you ask my mom, for example, like, oh yeah, you're writing code, and like, where does that go after? There's definitely those multiple steps before you actually have the end user. So I think that's going to be the spin we're going to be taking on it, is how does an engineer actually write code, and how does it get onto, master, and then the whole term, obviously dev cycle, we're going to get into that. So one of the other emphasis actually telling off that is when you work on a personal project, it's very different dev cycle than when you actually work in, a bigger team and organization to actually, put products out at the end of the day. I will describe my own personal dev cycle as like a wild west, where like, sometimes like one line change, like you don't really test it. It's like a copy change, you just deploy it immediately. But I doubt that can even happen. Even for a copy change, if you work within an organization, a lot of time that gets code reviewed, and that, goes through some sort of process before it actually goes on to master. So yeah, I think, let's dive into the personal stuff. Because I know like the personal project wise, like you're at home, you're sitting there, you're not going through like, you're not waiting for somebody else to code review your change before you put something on for your own personal project. I hope you don't do that, Stan, but
yeah, it's because I write perfect code. I don't need it reviewed.
But yeah, so if we talk about our own personal project, like Andy, in your past experience when you're, working on something yourself, like what was your dev cycle like? Was it literally just writing code, save it, deploy it right away, or did you have a little bit more of like thought process between?
Yeah, like on my personal projects, I probably follow a more stricter process than I do when I'm working for a company.
Wow.
I think like, well, I mean like when you're working for a company, it's hard to follow like a very strict process because like there's compromises you make, right? Mm-hmm. Like the feature has to go out. There's not enough time left. Like if I'm working on my own project, I dictate the timeline. So like I can easily budget time to make sure that everything is done correctly. And I think it's a good opportunity to basically practice like those good like processes too.
Mm-hmm.
I mean, yeah, there's definitely going to be always room for improvement on the corporate side if you're going to be working that way. What about your personal dev cycle like, Stan?
Well, a lot of the projects I've worked on in the past have either been like kind of small learning projects for my own sake or hackathons. So deployment is usually kind of like a second thought. It's like, oh, as long as I can get it out there. And most of the time, I don't set up any CI/CD. I don't really write any tests. Like if it works, oftentimes I'll just like spin up an EC2 instance and I'll like SCP the files over or something. If you have to install dependencies or something, I'll just like, remote into that EC2 instance and then just install it and then use like a basic like node runner or something, process runner to like kind of keep that server, up and going. Very, very, very manual process, unfortunately. But since I'm not doing it particularly often, it works for like those short-term projects.
Yeah, and I didn't even mention this, but like I didn't even ask like what kind of projects there were, because it's very different. If you're going to be working on the backend project that is like mostly endpoints or whatever, and you want to QA it, that's probably where you're going to spin up like a backend server, and then you could hit it whether through like a curl or whatever it is, and then you can see if your the response is correct by the time it comes back. At least for my experience when I'm working on personal project, I can even take my website, for example, right? perrytiu.com. Totally not plugging it right now. When I dev on it, that's clearly a personal project. I actually just run it as well on my local host, and it's just a React project, right? So whenever I put any change on it, any copy change, any new pages, all that, and I save the file, it automatically just refreshes and I can see it. So at least like in terms of QAing, that kind of where that happens. But what is interesting is that just because I also use a bit of third-party services that are actual real endpoints on different servers, they don't always work the same on local than on, I guess, prod. So that's kind of where stuff might get derailed. But I guess for my own personal projects, my dev cycle is literally, if there's a new feature I want, if, for example, I need to add a new section to the podcast page or whatever it is, I just build it on my local machine. I just tried maybe one or two different sizes, so mobile and that's kind of QA I would do, the extent of it. And next thing you know, I just save my change, I push it to GitHub, and I just redeploy it. So I think between saving a change and having it deployed is less than 5 minutes or so. So like, I don't like being blocked too much on my own personal project. I don't like having more process than that, because when I build something, I want to feel good and just put it out there. So maybe I'm not as like guardrailed than maybe Andy's lifestyle at the end when he does his own project at the end. But
do you have tests for your project?
I do, yeah.
Oh my god. That's impressive.
Yeah. Wait, why? Not why, but where do you find this discipline is probably the real question.
Well, it's fun to just try out, like, I guess, good processes. Like, because I'm just doing it by myself, I can basically try anything out. Like, I can try, like, several, like, CI solutions, like, several test runners, see what's best.
I see. But it does slow down, like, setting those things up is some decent amount of time investment in exploring those options. So it does slow down, like, your actual, like, feature.
I mean, it depends on like how long the project's going to last. So like if you do these manual deploys, I'm assuming each deploy is going to be what, like it'll take like 5 minutes of manual work, maybe less.
Probably
and then
less,
like
yeah.
Depending on how frequently you work on the project, say like you work on the project a couple hours one weekend and then you basically don't touch it for a month and you come back to it, like the time it's going to take for you to get familiar with everything is going to be like pretty significant, I think. So like doing all the work up front with the CI/CD makes it so that I can just hop in and out of this project whenever I want. Like if I want to put in 5 minutes, make a quick change here, all right, put it through CI/CD, everything's done, that's it. And then like I can end my 5 minutes of work.
That's true. That's a good point. Yeah, usually I just have like a bash script where I write out all the commands I use to deploy something, and it seems to work okay, but obviously I think that the real issues come is if you're working with someone else and they're not familiar with like those types of non-standard ways of pushing code and actually getting it into a production-like environment. And
I think that's the most interesting part is that, fortunately I get to talk to a lot of people who do have time to work on their own little personal project, and literally everybody has a different way of doing it. So you got the people that literally just code on prod. There are services that do that nowadays, right? I don't remember, I think it's like Cloudflare or whatever that has a service where it's like you could just literally change stuff, and when you save, it's pushed to prod, so you basically just don't have anything in between to do it. So I think for just anybody listening to this, like, and you're working on a project or building a website, whatever it is, there's not really like a perfect way of doing it. You could definitely have a load of guardrails, and then that may increase your deployment time just because you have everything set up already. And then there's definitely the other bit where it's like Wild Wild West. Just do whatever you want. It's going to be online. People are going to see it. So, but the contrast, I guess, that for the personal project side, that's what happens. Like everybody has their own personal process. And depending if you have worked in the proper, development cycle, you might apply that to your own life. I don't apply CR in my own life. Like I'm not getting somebody else to review my thing before I push out changes on my website. I should, but I don't. But if we do talk about the corporate lifestyle, if we do talk about working in teams and organizations that are, very software oriented, like there has to be a process to make sure that, where the tickets are coming from, they're being reviewed so that you don't have your own bias. Because obviously my code is perfect at the end of the day as well, and nothing goes wrong with it. But unfortunately there is code review and other people look at it. And then we could definitely explore the QA bit, because not everybody like has their own same QA process. And then even deployment plans, not every company has their own deployment plan. Some people bundle up where they deploy only once every 2 weeks, or every month, or every quarter or something like that, which is a little bit insane. And then other teams literally deploy every like 5 minutes, depending on how many engineers are on the team at the end of the day. So if we talk about let's bring back the word ticket, because that's kind of where our work comes from. At the end of the day, for any engineers at the end of it, I'm pretty sure like your work comes from tickets. Think about it at a restaurant, right? The tickets come in from clients' orders, and then you're the cook and you have to build it at the end of the day. One of the questions that starts this whole development cycle is where do tickets come from? Where does our work come from? Like,
They usually come from like I don't know, like the more business side of the company, basically the side that actually has to worry about making sure that the company has money to pay everyone. That can either be from product, it can be someone like in sales who has a new idea, it could even be like someone who works closely with the customer that can bring an idea from them.
I mean, that's totally in line with like, oh, a client is, I mean, we are building features for clients like 90% of the time. So if a client needs this supported, like a lot of times that's, the goal here. Even for all, I guess, if you take like Facebook's like marketplace platform, for example, and they support actual shops, whatever, and they request some kind of feature, like that's kind of where those tickets come in. And that's kind of, a duty of us to actually fulfill it. What do you think about that, Stan? Like, is that the only source of tickets, or is there, other stuff you've seen where our, software engineering job comes in?
Well, at least at Notable, most of our tickets are written by our product managers. And usually the product managers are the ones that are aggregating what types of features we should be developing at that point in time and prioritizing those and basically writing tickets for those and then kind of distributing those tickets to like whichever engineers have like the bandwidth to actually work on them. Yeah, but I mean, I would say most of the tickets that we get are more product focused. It's more like these are the features that we want, but at that point in time, if you get the ticket from a product manager, you might also need to break it down into how you're actually going to technically implement it at that point in time. So you might have like sub-tickets that kind of go over the process of how to actually implement such a feature within your existing system.
The world of sub-tickets. And that also runs their lives at the end of the day. So I guess, yeah, we kind of definitely do agree on the bit where most of the tickets that come in are client requests. So if they need to support a new feature, we'll usually do that. One thing I did notice actually is when we do have bugs of existing feature, those kind of counts as like source of tickets at the end of the day. Because yeah, we definitely did put something out previously, and then if something breaks or whatever bugs come in, then they will come in as a fresh ticket, and then you'll have to re-tackle those. I guess like that would be another source of tickets, basically existing code that that don't behave as much as you want. I would consider that as actually like reactive stuff, right? So when we're talking about like the product requests and the bugs coming in, those like are reactive just because something went wrong or something is new coming in. But on the proactive side though, like something that I keep on using the word for in terms of like exploratory, or like this is more on the product side when they want to try something new. So imagine you're selling a product and like depending on how you put your website together and what goes where. If it's like a storefront website, for example, like, oh, what if we put this product at the top and then description at the bottom kind of thing? Those are not exactly asked by anybody but the organization themselves. And then you need to, put that on an engineer's plate to be building that differently. So I guess that's another stream of if you want to be proactive on your own to find your job, as in like what you want to build. Like for my website, I keep on saying is that like, oh, what if I try putting like videos on my podcast page because there's not any of it? Then that's kind of where that comes from. It's because you want to explore different possible options. And yeah, at the end of the day, I feel like there's just a lot of streams for work coming in, whether it's proactive or reactive. But you did mention a point, Stan, where after that starting point, of getting these tickets being fed in by clients, customers, whatever you want to call it, it needs to go somewhere because fortunately the product manager has help. He's not going to be the one getting all of those and then building them. I mean, if the team is very, very small, you will see engineers actually doing a bit of that, which is a little bit intense. But what happens after the tickets come in? You started mentioning that they start delegating it, but is there some sort of process that you've seen in the past couple of years where team have tackled that? Or is it just like there's a list of engineers and the first one gets the first one and the second one gets the other one? Like what's the structure like when you're trying to delegate different tickets?
Yeah, I think there are a couple variables you want to consider when kind of doling out what tasks should be worked on by which engineers. Obviously, if it's a time urgent task, you might want to optimize for which engineer would be able to complete it most quickly. I think different engineers also have different reputations. Some of them are very fast versus some of them are more thoughtful and they introduce like less hacks. So you kind of have to take the makeup of like your team to determine who to give the task to. Another common variable that you want to consider is actually experience level, experience with that portion of the code base that you need to manipulate. Oftentimes it can be, you might be able to get a task out really fast with a certain engineer because they have the most experience with that portion of the code base, but you also want a little bit of redundancy in terms of knowledge share among the engineers on your team. So you may give it to an engineer that would, maybe do it a little suboptimally, will need to take more time to actually explore that portion of the code base just so, they can become more familiar with it. So giving tasks for the sake of improving an engineer's knowledge is also another common variable to consider when doling out, tickets or tasks.
If you want to be the cool person that works in tech, just throw out the word bus factor, which is usually the term that people use, where it's like, if you want to, kind of, spill out the knowledge a bit, not just have one single point of failure, one single person that only that person knows how to work on this code. The idea of, if you want to delegate a task, even though somebody else knows it very, very well and could do it way quicker, by delegating it to somebody else that hasn't seen that part of the code. I think that happens very, very often. And the idea behind it so that you mitigate this bus factor, where if somebody gets hit by a bus and they get taken out, it's not the end of the world because somebody else will be able to kind of come into it. So yeah, fun tech term for you guys out there. What about your idea in terms of like, Andy, how are tickets, I guess the term I use is like t-shirt sized. Like, how do you know how big a ticket is? Because, for example, you can't just take a ticket and like shove it to somebody and expect them to be done in within a sprint of 2 weeks, for example. Like, what did you see in the past couple of years in terms of how tickets are t-shirt size, and how do those fit in, I guess, in sprints?
Yeah, you basically just want to make an educated guess, because like typically when you do sizing, you do it ahead of like some other planning, and you kind of like take that size into account when you're planning out like timelines, for example. Ideally, there would be no sizes on any tickets, because a ticket can honestly be any size. Like, you can work halfway through a small ticket, and out of nowhere you realize you had to go and refactor like something huge. But yeah, like for the sake of like further planning, like an estimated guess or a educated guess is like the best we can do. Just like based off of what services is touching, how large do we think this change will take. What's like the state of the code base? Like, will it be easy to do this, and so on.
Yeah, I agree with all the points, because it's not easy, obviously, to guesstimate a size for a ticket. And if people are looking to get, I guess, like to be better as an engineer, like that's definitely one thing that over time you definitely improve on, and that kind of qualifies a lot of people. If you're really good at getting those stuff and really able to judge how big a task is, I guess you're definitely a better engineer and more senior engineer over time, just because you've seen a lot of shit in that happening. One thing that is, I guess, like, it's pretty obvious if it's like a copy change, for example. It'll be very, very easy to log in and just be this copy change at the end of the day. And then if it's, as you were saying, if it involves multiple people, multiple engineers to do that, who usually, I guess, t-shirt size this? Is this the product manager? Is this the engineers? Like, from your experience, have you seen like very successful cases where, is it a product manager that managed to able to delegate these tasks very, very well, and that's how you stick onto schedule? Or is it mostly engineers? Or have you met something like a technical product manager who, somebody who have been, I guess, on both sides, and then being able to t-shirt size these properly? What do you think's that?
I've seen a couple strategies. I've seen technical leads for teams do all the estimations. I've seen like kind of like a more democratic process among all the engineers, where they kind of play, was it like the story point poker or whatever? Yeah. Where they just kind of average. Yeah, where they just kind of, everyone throws out what they think is how long it's supposed to take, and then they just kind of average it out, or they take like the most common estimate. I've seen those are the two that I've seen most commonly. I haven't worked with any PMs that actually did all the estimations themselves. That's not something that I've seen, but potentially there are teams like that out there where it works for them.
That person would be freaking impressive. I mean, yeah, they do exist, to be fair. But I think, like, when we're talking about the synergy between PMs and engineers, like, this is probably the highest friction zone. Not friction zone, but that's the highest contact, where you're trying to size stuff. And then that's where the tech lead or like the tech architect, the engineering architect kind of comes in and like kind of gives their opinion in terms of like, oh, how much work this needs to be done. And then the ticket is broken down. And then, as we were saying, depending on how it gets assigned, who has seen it before, who has not, how time urgent, that's kind of where these tickets flow at the end of the day. So far, everything that we've discussed, like we haven't written any code. Like as engineers, up to this point, there isn't a single bit of code written. There might be some exploratory stuff happening, like, oh, maybe we could just do a small MVP to see if it's viable or not. I think they call them in a technical term like a spike to see if it actually, works or not. But if we talk about by the point that all this is spec, so now that we have a feature that came from a client, it came in, so many eyes looked at it in terms of planning it, so how big it is, how delegated it is. We're in the deving phase now. So this is a deving phase of a cycle where you just got to go at it. What is, I guess, your process in terms of how do you start a ticket? Do you jump straight into the code first, or do you try to take some time to review the adjacent code that it touches? Like, how do you start a tickets then?
Well, maybe not me starting a ticket, but generally I want to understand all the specs for a given feature that needs to be implemented. And at that point in time, if the feature is large enough, or I think the complexity of implementing it is high enough where I would need to kind of think about it for a little while, I generally try to write up an RFC, like a review for comments at that point in time before I actually start any actual coding. Make sure that gets reviewed by other stakeholders that understand that portion of the code base. Basically try to avoid any pitfalls where our plan's timeline might deviate significantly because we didn't consider something somewhat large. And then at that point, once the RFC has been approved, you kind of break it down into implementation subtasks, and then you can just work through those tasks from there. But that part is relatively simple to like the overall planning portion, in my opinion.
Yeah, that's fascinating that I mentioned that. For an engineer to find the easiest part is the actual writing of a code is the easiest part, considering all the other processes.
Yeah, I think as you get more senior, like a lot of coding is being able to anticipate what's going to happen. Like the best engineers are the engineers that have a lot of foresight, and this can come from either experience in general, like programming in general, or like experience with a specific code base, experience with a portion of that code base. A lot of these things like help you anticipate what kind of pitfalls to avoid and what are like the things you should account for when implementing something.
Yeah, and that's kind of where all these like dry, don't repeat yourself kind of comes in, where it's just because you've kind of had this higher level view of it before you actually just jump into it. You kind of save yourself a little bit of pain over time.
Yeah. Like ideally you implement it in a way that's extensible for the future, and like the more you understand about that portion of the code base, probably the more educated your guess is and will be for how to actually implement it in like the most efficient or optimized way.
Yeah, such a big contrast in terms of when I work with my own projects. Like, nah, just build it. Just dive into it. Forget about the RFC. Like, yeah, I'll put it out there and see how that goes. But no, I definitely agree. I guess like when you work within a team, that's super important. And at the end of the day, I've seen that enough that it pays off. Like if you do take the time to write those RFC, put it into context in terms of, do we have an endpoint that exists already? And if it does, you could just reuse that endpoint instead of building a new one. Like that's usually stuff that you could come across. So really cool with that kind of dev process. What about you, Andy? When you're starting a ticket that gets assigned to you after the whole planning phase, whatever, what does your work process look like from that point?
It's pretty similar to Stan's. Like I definitely like to kind of think of like just take time to look through the spec and pretty much come up with like a more technical version of the spec for myself. Like, I don't know, like take inventory of all the resources I have, like whatever tools I might need to use, like parts in the code base I'll have to touch. And like after all of that, after I have like a somewhat detailed enough plan thought up, then I'd actually get into the actual like implementing, like basically like hands-on keyboard phase.
Yeah. Do you agree that's probably the easiest part of the whole dev cycle, I guess?
Oh, definitely, yeah.
I think that's usually... Yeah, because that's usually the part where when you look at a dev, most of the time when they're focusing on the screen, that's probably the phase they're in. They're just looking at the code and just writing it. And I guess like people might assume that's probably like the big chunk of a dev's day. time. For example, like you'd assume that, oh yeah, a software engineer, they probably code like 95% of the day and the rest doing, whatever devs do. I think this is just a good contrast to put, just because like mostly the bigger chunk of the work is figuring out where stuff goes before they actually go into it, and it does pay off. I think like if I have to speak for myself in terms of my dev process is, yeah, there's definitely a balance between instead of jumping into the ticket immediately, except if it's like a copy change. That's obviously the example I'll put out there, is that like maybe there's not going to be that much uptime to actually get started in coding. There are very frequent cases where before you even start building the feature, you have to have some sort of agreement. If you are working with other engineers, for example, like even the data model or like the data structure at the end of the day, that always comes into question. And that's a lot of work that needs to be put into there, time consuming, and that's take a good part of your day at the end of the day. So whether you're a software engineer that only writes code, I'd be skeptical about that, because most of the time you'll see software engineers doing way more than just, cramming out the code. And I will agree that when you get to the point when you're actually writing lines of code and like, the syntax, for loops, whatever you want, like that's probably the easiest part of the whole thing. Because at the end of the day, those is just, actually putting the mental work into paper at the end of the day. So, but don't get me wrong, I that's probably the reason why people love coding at the end of the day, because that's when you get the fruition of finally putting your plan into an actual project. Whether it works or not, I don't know, but
I don't know. I like the planning stage more. I feel like that's like that's like 90% of like the difficult stuff is figuring out how to integrate like your plan into like the existing system. I think when you're working on like very new features that are kind of at the edges of your system where you can just like bolt on new stuff, oftentimes that's like it's like okay to write an RFC, but it's usually pretty low risk. But when you're working with like a more legacy type system that has like more and more history behind of it, there's a lot of complexity in terms of like how do I change the existing data models to account for this new feature, and that stuff gets very complex. I think there's a lot of enjoyment in like thinking through that complexity.
Yeah, one thing I do want to point out is during that, we're still in the dev phase of the whole the implementation, the writing code bit of the whole dev cycle. You would imagine most of it is alone, I guess. You would have one engineer and that's where they sit, their mindset is. But that's not always true from the experience I've seen, actually. If I start throwing words like pair programming or even the RFC phase or even just like getting more feedback on the architecture, it is very involved with multiple engineers. So I guess just in general, do you have like, I guess, good experiences of like pair programming, for example, Andy, like over the years? How does that help people during that dev phase in the dev cycle? Or what is pair programming? Let's do that first.
Yeah, pair programming is basically when two engineers are working on a task together, typically with just one shared computer and one IDE. I think there's normally a driver that actually does all the typing, and then there is can't quite remember the other term for it, but the other person basically provides like the direction. I don't know, the navigator or something.
Yeah, I don't have a term. I was going to say shot caller, but no, that's definitely not a technical term for it.
But like pair programming is incredibly effective in my view. It's a really good way to have knowledge transfer between like more senior engineers to more earlier engineers, and it's a good way to kind of reinforce like what the senior engineer knows as well.
And you just hope that they know their shit. You just hope that they're passing out the good stuff out there. No, I'm kidding. I think everybody has their own approach. As we have, spoken already, everybody has their own approach to starting a dev ticket, and even during pair programming, everybody has their own approach. So I guess like that's something to include in this phase, in this whole pipeline of just, moving the ticket along and everything. One thing that I guess like at least notable that people do put a lot of attention is when you are in the deving phase, you are doing your own diligence of adding tests and making sure that it works. So as your own individual engineer working on a ticket and everything, you do spend the time to, make sure it works at the end of it. I'm just repeating myself. How does one do that? Not exactly notable, but how does one make sure that the code you've written, actually satisfies the ticket?
Well, again, it's how you test something is very dependent on what you've actually implemented. I mean, testing endpoints is different than, testing functions. There are different methodologies for how to do each of those. I think like a general testing principle is that one thing that I really like to take into consideration is that when you're testing a new feature, you kind of want to be like the bad guy trying to break what you've just written. And if you think there are areas that are you've written something in a way that is easy for it to regress in a specific way, you might also want to write tests that kind of assert that specific behavior to make sure it doesn't break. I think a lot of it is just anticipating how other people will interact with your code in the future or make modifications to it, and writing tests that will, protect them from themselves or yourself, like in the future,
Yeah.
Because oftentimes you revisit code and you're like, well, I don't really exactly remember what I did here, but hopefully my test coverage, makes me feel comfortable enough to make like somewhat significant changes to like the actual implementation if like the interfaces for that function is still the same.
Yeah, I think that's where definitely the discipline comes in now. Because when even I remember like the first day I started as a software engineer, like the word test and unit testing and all that, like that was like a culture, the culture of like writing your own tests after every change that you put out there. It's definitely been ingrained in the whole time. What do you think about that? Do you think that, during the phase where an engineer is working on a ticket and developing it, implementing it, like they should have this habit of always writing tests in their code? Is that something that you would recommend, Andy, or?
Yeah, I think writing tests is super important. I mean, one, it like you basically need to prove that what you wrote works. Like if you don't test it, then like what's you kind of like wasted your time. I think writing tests as much as possible is definitely a good thing. I feel that after like a certain like experience level, writing tests will always be faster than just testing it out manually. Mm-hmm. Especially for more complex systems too. So yeah, like it's gonna be more efficient because the tests are gonna be there. They'll always be ran whenever CI is run, and yeah.
I actually kind of have like a more nuanced perspective on testing. I think like oftentimes people think more tests is better, but I hold the opinion that that's not actually the case. There are like a few factors that you want to consider. Like one is like how many other people like are working on your team. I think tests are there to prevent regressions that might otherwise be very difficult to catch if someone is to be modifying the code. If you're working with a bunch of super good engineers who all are very good at reading each other's code, I think you don't actually need to spend as much time testing. There's like one of like the most famous like computer scientists, like Donald Knuth, that guy, who's written like very famous like programming books. He's like, yeah, I don't really write tests for my code because like I mostly program by myself, and I've programmed for so long that I'm like very, very confident in what I've written is correct. So by spending like the extra time of like writing tests, unless you're trying to prevent someone else on your team from like making a mistake, it's not always beneficial. And there is like a time cost and a maintenance cost to writing tests as well. So I would say for the majority of teams, like you probably should be writing tests, but you should also be very thoughtful about what kind of test you're writing. Like don't just write like boilerplate tests because you've seen it and you've copy pasted it. Try to be like thoughtful about like what assertions you're making. Like what are you actually trying to prevent from regressing in the future?
Yeah. And funny enough, you don't always get to choose your team. So I do get that there's like different landscape and depending on, what you get put into. But yeah, before we jump into the whole CR bit, where obviously like as an engineer, you have your own bias that your code is great.
Oh, it is great.
Yeah. One of the things that I can mention is comments in code. How do you feel about it? There's different camps to it. It's just the same way as tests. I feel like there's many camps in terms of how people feel about comments. So I guess I could just throw mine out there is that one rule or one like kind of tip that I've read, many times across the internet or even people just saying it is that like whether you name a variable clear enough and if you write your code clean enough, you shouldn't need any comments, just the way that if you're writing your functions in a logical way and everything, you should be able to just read it and not rely on comments. That's kind of what I've tried to do over the past couple of years, that even naming variables, I've definitely put way more effort in terms of making sure that I don't need a comment that says like, this variable is to store whatever it is. Just name the variable, what it's storing, like clear enough, and then that should help on it. So I guess that's kind of where my stance and my, work experience has been. What does yours look like in terms of comments in code? Because this is definitely still during the, deving phase of an engineer.
Yeah, I think like my opinion is somewhat similar. I believe almost all code should ideally be self-documenting, especially if you have like a typing system. If you're using a typed language, oftentimes like then you get around a lot of like the, well, what type is this supposed to be, and as opposed to like the dynamic programming languages out there. So if you're using a dynamic programming language, sometimes I think it's beneficial to add like types in the comments. But if you're using a type language, you don't need to do that as much. The one time I do think adding comments is important is not you to explain what the code is doing, but why you're doing it, because oftentimes that is not very apparent in the code. Like historically, why this function might be really messy and like don't touch it, but this is the reason why you should not touch it, right? Like it's because of like this history, and then put out a warning for people in the future, because no matter how much we want to write perfect code, that's scalable to like the infinity in the future, we're human and that doesn't happen. So it's important to like warn people, the future people.
Yeah. The ones where you just leave this line in.
Yeah, I mean, you should tell them why. If you figured out why you should leave the line in, like put it in there, but also leave a comment like, yeah, don't touch this line, because you're probably gonna run into something. Or you could write a test, make sure that you could assert that line is not changed potentially.
Yeah.
Andy, of course, like what do you think about comments in code?
Yeah, I share a very similar opinion with Stan. I think most code should definitely be self-documenting, but it's hard to convey like intent with self-documenting code, so sometimes you just need comments.
Yeah, they should be fairly far in between. It's also like to-do comments.
Yeah,
my opinion is like if you're gonna write a to-do, just write a ticket.
Yeah, I totally understand that. One thing you don't want to see is people having conversation in comments. from one revision to another, you just have like comments that are just basically talking to each other with different people. I think I've seen that over the past years of working in software engineering, and I was like, it's enjoyable to see, but then again, is it productive? I don't know. But yeah, that's pretty cool, because everything that we've spoken so far, this is like, we've talked about our own little world of deving, or if you're pair programming, obviously there's going to be multiple engineers into that. But after that point, so that's basically done. You've done your own testing. You've done, if it's a actual component, you've done, clicky around and see if it works and everything. The next step is like code review. This is a term that if you do work as a software engineering job, like you can't really run away from it. I don't know if you guys have ever worked at a job that didn't require really code review on that, but for the people, I guess, less familiar with it, I guess, what is code review to begin with, Stan?
Actually, I have worked at a place that did code reviews, but it was not a very good place. Let me think. What is a code review? It's reviewing code, I guess. It's kind of in the name.
In terms of like the physical process, though, imagine like I'm writing something. So I'm on my IDE, like WebStorm, whatever. I finish my ticket, so I make a branch for it. Then what happens?
Well, I mean, independent of like what kind of version control system that you use, regardless of whether maybe I think reviewing code in itself is just reviewing someone else's code, ideally before that code goes into some type of production environment. But it's a very good tool for preventing bugs, knowledge sharing. I think it's a very valuable process to implement in, I would say, pretty much any engineering team. Again, no one is truly infallible to everything. So even though, some review processes might be more lenient because like you trust an engineer more, but I think like implementing it as a block before you can merge code is almost always like the right move.
Yeah. I mean, like, and it's funny because it's not only like specifically in the tech industry, like there are a lot of similarities with other industries. Like, for example, if you're going to be writing a book, or like if you're going to be producing some kind of documents, like there are editors that after you written your chapter or paragraph or whatever, you send it to the editor, and then they'll have their second pair of eyes on it. And this code review process is very similar to that. Is that after that you've produced your code and everything, this is kind of where you get somebody else to look at it in a different light and see if they could point out stuff that you may have not have seen when you're doing that. And the example I brought was that if you're on, if you're using Git and GitHub as a combo, then in my case, I will make a after I'm done deving it, I'll make a new PR, new pull request on it, and then I'll start assigning other engineers to look at that pull request. So the changes there. One thing that I find it a fun topic is how do you assign a ticket? Who do you decide should look at your PR at the end of the day? I don't know if people have opinions on it, or do you just find like the closest engineer like that kind of thing? Like, do you have a process in terms of assigning your code reviews to other people, Andy?
Yeah, you generally want someone who is familiar with like where your changes are. Like if you like for example, if you're working on the front end team and you assign your React PR to, I don't know, someone on the machine learning team, like you're probably not going to get that much valuable like info out of it other than just basic like syntax like checking.
Yeah, I totally agree with that. And then how do you know somebody is a ML or React engineer? I think like that's for another topic in terms of like how you figured that bit out. Do you have the same process? You always assign the same people every time you have a PR out there, Stan?
It kind of depends. Like I kind of have like, if I have like I have different people that I go to for different things. Some people, they're faster at reviewing code. So I send my pull request to those people when I need something that I know is like pretty low risk, but I need it reviewed quickly, versus someone that I want to read through my pull request a little bit more diligently. Like I think people have different reputations for how they review code, but it's very hard. I know there are a lot of companies that try to standardize how to code review, but it's pretty much I have not seen it standardized. Mm-hmm. Everyone kind of has like their own different way. So just knowing how to navigate that environment in terms of who to send that code to review can be difficult without experience.
Yeah.
One thing that I've seen that is kind of effective is like kind of like a code owner file. Like, so you say like, oh, these people own these portions of the code base, so they have to approve. If you're going to push code into this portion of the code base, like they need to be approved. That can be a way to like kind of establish a more formal process that's not just like you picking like the most lenient reviewer just to get your code in. Yeah.
I was literally actually going to say something similar to that in terms of, for example, the Git history of a file. Like that may be a good indicator, depending if the person like touched that bit of code previously. Like that could help in terms of identifying somebody who has previous knowledge and be able to give an opinion if somebody else touches the code, just because context wise, like they have seen it and they'll be able to, maybe if it's not obvious in the code already, assumptions that the next person touching it might not have, then that's where the code review comes in. And that's why it's super helpful with the history of, the whole bit.
Oh yeah, GitHub has like that feature, right? Because it suggests like which reviewers to add. And I think it's like variable based off of like, it weights it more if like that person has modified the code recently that you're also changing, but also considers the other people that have touched that file.
Yeah, I don't listen to any of that. I usually just pick whatever I need to at that point. No, it is helpful to be honest on that. Actually, one of the good thing that you mentioned before is not everybody has the same way of code reviewing. So as an engineer, one of your responsibilities is also reviewing other people's code at the end of the day. So yeah, you do write a lot of code. But when I was saying that, like 95% of it is not just writing code. 95%, like it breaks down a lot more in like planning the ticket, planning the architecture behind it, but also code review is a big chunk of your day at the end of time because you got to factor that in. I do want to pick out your brains, obviously. Like, what is your code review process? What are you looking for? Any tips, I guess, for people that do have the code review all the time? Like, yeah, give us a bit more, Andy.
I pretty much check to see if like certain processes are being followed. Like, are the changes in like the appropriate areas, like file structure, how like the code is written, have they written enough tests, or like the main thing I want to basically focus on is that if they have followed all of the processes that are laid out, then the logic itself should be good enough. Like if they've written good tests for it and the tests look good, then the logic probably is good as well.
I think one thing I'd like to add is like the first thing I usually check is like, is this the best way to actually solve like the problem that we're doing? So I usually, before I even start like reviewing the code, I'll like look into like the ticket that they're working on and see if like there's an RC associated with it. And then if like their solution kind of makes sense for both of those, then I move into reviewing their kind of the higher level interfaces that they're introducing into the code. And then you just kind of get more and more detailed. Then you look at like test comprehension, like Andy mentioned, and then maybe eventually some of like the function implementations. But function implementation is like it's easy to swap out. There's also some smaller level stuff like variable naming, making sure they follow like the standards that we've set in our code base. A lot of those are like more nitty type things, but they're good for like, again, knowledge sharing to make sure we have somewhat of a standardized code base.
Yeah, it's definitely super helpful because the way you approach it, because I follow a very, very similar process. When I do code reviews is I kind of go from a very high level to low level process. And when you're talking about like, okay, context, first of all, like what are they trying to accomplish? What is the ticket? What is that? Like, I love it when they actually have those stuff documented. So when you're able to look at a ticket and click on a link, and whether it's like a Jira ticket or whatever it is, and it tells you, okay, this is what we're trying to build. And then you put yourself in their shoes, right? You kind of go to the point where it's like, oh, if I had to do this, how would I do it? So then like you kind of have a mental image of your kind of opinion. And then when you start reading the code, that kind of where you kind of have this extra set of matching to see if it actually, goes into a similar direction to how, I guess, your opinion would be at the end of the day. And then obviously emphasizing on the high to low process, that's kind of where you start. So very, very high level in terms of the approach. And then you mentioned the interfaces, which is a great point because the data model kind of comes in after, where it's like if they kind of respect this data model at the end and they have these like similar ideas of, oh, they're storing this in a very specific state that will cover all the cases possible, then that gives you more and more confidence. And then by that point, that's when you start kind of reading all the specific lines. If you see a function that you don't know where it is and it's not part of this ticket or this PR, sometimes I'll actually go back into the code base and see where that kind of leads you to. So like I do find myself a lot of times not only looking at just the code that is in the PR that has been changed, but I do sometimes just explore way more in the actual project in my IDE to figure out, what has changed at the end of the day. So I guess that's kind of my process. One of the things that I guess I'm infamously known for, not in a bad way, but like the nitpicky stuff. So I'm never gonna stop a PR for just because they wrote a for loop differently than instead of using like a map or whatever. Like those are like the very low level details that you do see in CR sometimes. Is there a smarter way to use this? Is there an existing function that does it better? Is there like a package that does it better? Like if I speak from my experiences, those are not blockers. There's no way that like that's going to be requesting a change before the PR goes over, but I'll be the person that will point it out. If there's a way to write whatever this syntactically better, just because I think like over the years, it'll make you better at the end of the day, I'll point it out. It might be annoying, it might not be, but is that how you guys agree on this, where it's like the low level stuff, like they're not blockers, but do you go out of your way to point it out? Like, do you go out the way how somebody is creating an array or something? Like how do you deal with the very low level stuff in CR?
I think it's very dependent on like who I'm reviewing it for. If I know this person doesn't really respond or address like those types of comments, I'll just eventually stop making those comments. But generally, if they're more open-minded to actually learning those things, which is generally engineers that are just coming on and are really trying to get like, what are our code standards? How do we generally write things? I will leave as many of those that I've noticed as possible. And then again, if they don't seem responsive to those comments, then I'll just eventually back off because they probably will eventually get annoyed if I continue to make them.
Backing off, what's that? I'm kidding. What do you think, Andy, in terms of, I guess, the lower level nitpicky stuff during CR?
Yeah, it basically depends on like how long they've been at the company and like how aware they are of like the kind of like implied code standards. Like if they're fairly newer, I will definitely leave a lot of those comments. But then like as they spend more time here and as they get familiar with the standards themselves, I'll like slowly wean off of that and stop.
For me, the biggest thing is there was a period of my life where reduce was everything, even though it wasn't necessary. And that was the point where it's like, why are you using reduce for that? Why are you doing it? So those are the kind of conversations that at the end of the day, not a blocker. Your ticket is going to like be fine with or without it. So I feel like in terms of like, when we're talking about the high level of CR and then you just go lower and lower level, let's just make sure that, I guess the tip here is at least when I do CR, I just want to make sure that the high level, the architecture bit, where it's like the ticket it actually meets the criteria, that's probably the bigger focus is at the end of the day. So
yeah, different companies are like more or less stringent about these types of things. Like some companies, you really do have to meet all like their standard practices before you can merge anything. Like I think a renowned, infamous example is like Google, right? Like they make you rewrite supposedly, oftentimes they make you rewrite your code like multiple times, like for like 2-3 weeks before it's like merged into production, because like they want it to be standardized with everything else that they have written for that team. But different companies have different standards.
Yeah, if you want to standardize, it should be automated at the end of the day. If you want
code style is so hard to it's so hard to like automate, right?
Yeah, I think that's for another topic, to be completely honest.
Maybe GPT-4 will be able to write standard code for us.
Oh man. But yeah, I think that's at least a good enough picture of what code review looks like. Obviously many places do it very, very differently, but I guess like the essence of it is definitely there. And I guess like the last few bit is basically QA, which stands for quality assurance. That from company to company, that is probably the most different phase that you could, see from different companies at the end of the day. So for example, like there are companies where I think one of the companies I used to work at, the QA phase is basically, you done your own, your own testing on your machine, whatever. If it's like a front end change, then you could write your own unit testing. You could do your own, I've clicked around and like I've done the whole bit. And then what happens is that by the time that gets merged, so you go through code review, gets merged, there's actually another team called the QA team that actually comes in and then tests it before anything. Well, it's actually merged in the staging environment. I'm sorry for that. It's not merged on prod. It's merged onto the staging environment. Well, deployed on staging environment, and then the QA team comes in and then does all the QA stuff. So that's one of the process that I've been exposed to, and also I guess like the QA phase is the question here is who does the QA in your experience for like different scenarios you've seen, like who does QA and how do they do it? Just because everybody's so different. What do you think about that, Andy?
What I've seen in the past is just like the individual engineer doing the QA themselves. My experience is only limited to pretty early stage startups. So I've definitely heard of like dedicated QA teams before, where they even have like people who will write tests for code as well.
The title of quality assurance engineer, just like writing frameworks all day, like that sounds. It's definitely out there at the end of the day. What do you think, Stan?
I don't know. I guess I've seen like dedicated QA people, and I've seen that kind of QA role rolled into like just the responsibilities of like the software engineer who is actually writing the code. I don't know. I do think I probably lean more towards like a software engineer should like QA their own code. I think having that responsibility on themselves pressures them a little bit more to actually write better code, as opposed to like being like, oh, I know I have a fallback eventually, and then they'll catch it, in staging, and then I'll fix it up then. I think that can kind of breed a bit of a lazy coding mentality, which isn't very good. But I don't know. It's also hard to say, because I will say that companies that have engineers also working on QA oftentimes also don't know how to write tests as comprehensively as people who are just dedicated to that role. Like there's so much knowledge around how to actually write comprehensive tests, and metrics around it, and it's hard to be very professional at that and also be like pushing out all these features and all this code that is not necessarily related to that all the time as well. It's hard to say. It's hard to say which one is like better. I think it also depends on like the product that you're delivering on. Like QA for like web-based projects, if it's just like a website that doesn't have too many people on it, it's like an internal web application. Like it's not as important for it to be. If it breaks for a little bit, it's probably fine. So maybe you don't need to have as stringent a QA process, but for stuff that impacts a lot of people, you probably want a lot of guardrails, one of which might be a dedicated QA team. Mm-hmm.
Yeah, so at the end of the day, like this is where the point where the QA phase of the dev cycle is so different everywhere. And one thing that has been very impressive over the past couple of years is when we talk about automated testing, that just I guess like it kind of saves in manpower. It's kind of taking the QA's job at the end of the day. But when we talk about automated testing, there's so many tools out there that whether it's a front end change or a back end change or an API change, whatever it is, there are tools to do it. So even if you want to simulate a user going through your web app with the new changes, those can all be automated out there. So if we're talking about at the end of the day, the whole point is that you want quality assurance. You want to make sure that the code that you put out there doesn't break stuff and the user flow still works at the end of the day. The emphasis and the love for automated testing has been very present, at least in the past couple of years from what I've seen, more so than ever. And yeah, I think like if anybody's just thinking about the whole, I guess, problem of QAing, do you want to hire a QA team? Do you want to have just very good engineers that know how to write really good automated testing? Those are different paths that I've seen, people take at the end of the day. The other thing about QA that I do want to mention, it doesn't really count as QA, but there's YOLO deploys, where you just put it out and see if see if any tickets come back. I guess that's one way of QAing it. No, to be honest, that doesn't count as QA, but it does count as, I guess, the last phase of deploying, which basically means after all that hard work of CR QA, not to mention that the cycle over there does, if you go from CR and then it fails CR, then it goes back into deving, and then when it fails QA, it goes back into deving again, and that cycle could go on and on and on for like ages. The reward at the end is definitely deploying. We could talk about that in terms of like what happens, like what do you do when you're past QA, or like when you're past CR and like everything's good? What happens to your code?
It varies from company to company. Depends on whether you have a staging environment, what your release cycles are like, what kind of, again, the release cycle intervals might vary. It could be weekly, monthly, quarterly, could be shorter than that. At Notable, we just kind of pretty much release to production anytime, and we try to mitigate all of our issues before we release. So ideally, we have a comprehensive test suite that catches regressions before then. It depends on where you actually built up like your checkpoints for catching regressions. Yeah,
I think that makes sense at the end of the day, because by the time all the green light has been given, right, the code review, the QA, like that's what the green light is, and that's when different teams, depending if you have to deploy to staging first and let that live a bit and see if the third-party integration works with the staging environment. That's one way of seeing that, and that's kind of past QA, I guess. That's like you're basically ready to go and you want to deploy all the stuff. And the other bit is basically on other teams where green light, all ready to go, all the test passes, you merge it onto master, and then you press a magical button that redeploys the project, and then the project refreshes. The next thing you know, the next user that goes onto the project sees the new changes. So I think like that's kind of where the deploy phase of the dev cycle kind of comes in. Is basically you got all the green lights, got all the confirmation, and that's kind of where the satisfaction is that. I don't know, do you guys feel satisfied when your code goes on live, or do you just feel like, that's fine, but it might come back to bite me because, like, I don't know what's your sentiment after so many years working in engineering. Like, what do you feel after you put your code in production?
I feel fear. I am just scared it has broken something, despite all the checkpoints that we have, that, it got past all those and it has broken something. I don't know if I feel that much satisfaction these days. Maybe I'm just old and jaded. I'm just scared.
You've definitely been scarred by the software engineering industry. I do agree with you where it's like my biggest fear when you deploy is that you deploy something, but something that's broken, but you just don't know about it. Like that's probably the paranoia that people keep on thinking, that it's lingering. It's definitely a thing about there. But no, Andy, what do you think about what's your feelings when your code actually hits production?
I still feel good, so maybe I'm not that old and jaded yet. So.
Yeah, give it another 2-3 years.
Yeah.
The countdown is on everything. No, I think a lot of people do share that sentiment of, the satisfaction, whether it's a personal project or when you're at a company, you're contributing code, like especially when you talk to people that are not there for a long time, for example, like interns, right? They'll be there for a summer project, whatever it is. And when their code hits production, it's significant. It's like rewarding. It's there just because you made your impact. That's probably where the footprint is, that you made your impact, and then that's, all the deploy phase. So I guess everybody enjoys it differently. For me, personal projects deploy every single time, like more than happy. Like a new like a link button on my podcast page. Like absolutely love it. You know, the one where you could just like the anchor and it auto scrolls all the way down. That's a new feature. If you guys haven't seen it, go check it out. But
yeah, that's some advanced stuff right there.
Yeah. You try it. No, I'm kidding. But the other part of nowadays, like when I do release stuff, at least at work, and then just the whole paranoia, because I do know there's like thousands of users that will see the change within the next couple of seconds, not even. Like that instills a bit of fear. So hey, everybody has their own story about deploys, and that kind of closes off the loop of, you know, the dev cycle. Hopefully that gives a bit better picture in terms of like we don't only just write code, we're not just all code monkeys at the end of the day. Some people are. Go.
I am.
Go them. But I guess like in terms of just in general, like if you just want to have a quick point of what has worked well in the dev cycle, or maybe your favorite part of a dev cycle and what has worked less well, maybe that will help other people listening to this, how they actually tweak their dev cycle at the end. So do you have any thoughts about that, Stan?
I think the parts I like to emphasize in the dev process are the RFC, so kind of the higher level planning and the code review process. I think those are the ones that I like to focus on between me and my like more immediate peers. I think like focusing on those makes you a better engineer faster when you focus on developing how to work on those parts well.
Yeah, I mean, that makes sense. And I guess for you, Andy, in terms of like, as somebody who is looking at the whole dev cycle, like, and somebody who even start from scratch and want to make a dev cycle, like what kind of, I guess, emphasis you want to put on which part of it that would be useful?
My favorite part of the cycle, and the part I think is most important, is definitely the planning phase. Like, I think it's super important to just take some time and like just really take inventory of everything you have. Make sure you're using like everything you have properly. Like if you go and kind of just like dive deep into a project without like actually planning it through, like there's a chance that it'll go well, but then
for now,
exactly, yeah. But then generally it's just not gonna go well. Like there's a saying from one of the founding fathers: if you fail to plan, you plan to fail.
And that's
true.
Yeah. And I guess that definitely summarizes the cycle at the end. So I think like just from my point of view in terms of like the whole dev cycle thing, like I think my emphasis is literally on the word cycle, just because it doesn't stop. It's just like you go through the dev cycle and it will come back. It's just a loop.
That's morbid, dude.
Yeah. So I think like if anybody's looking at this and trying to improve it or whatever, I think it's like just make one cycle better than the next one. Because stuff, as you were saying, will go wrong during the whole thing. And then like whether it's during the CR, whether during the QA, or whether during the planning, that if you as an engineer, you as a product manager get annoyed about something, then if you don't fix it, then it's just gonna get worse over time. So find ways of improving each step of it, and then the dev cycle is gonna be hopefully more enjoyable for everybody. So I think that's basically all the topics I wanted to cover today. Thanks again for being on the show, Stan.
No problem.
Always love seeing you as well, Andy.
Thank you.
And I'll catch you guys on the next one.